Let us introduce moving averages. Prices can be volatile. Moving averages attempt to reduce this volatility in prices and provide a smooth trend and reduce the distortions to a minimum. In this lesson, we'll examine three kinds of moving averages, that is simple moving average, weighted moving average, and exponential moving average. We'll start the discussion with computation of simple moving average, its properties, and visual examination. We'll highlight some of the key properties of moving averages and various moving average technical indicators in determining technical trend and its violation. We'll understand how to generate timely buy and sell signals with moving average chart. However, there is a trade-off in timely signal generation and the accuracy of the signal, which we'll understand through the discussions in this lesson. We'll also understand the application of system of moving averages, for example, dual moving average or MA system, such as short-term and long-term MAs, in identifying trend and trend reversals. We'll also draw parallels between moving averages and price patterns, such as formation of trend lines, trading in ranges, classic patterns, among others. In this video, we'll introduce the concept of moving averages. Moving averages are employed because prices can be volatile, and moving averages attempt to reduce this volatility in prices and provide a smooth trend and reduce the distortions to a minimum. Three kinds of moving averages are often employed. These include simple moving averages, simple MA, weighted moving averages, WMA, and exponential moving averages, EMA. Moving averages, like trend lines, provide dynamic levels of support and resistance. Moving average is like a simple mean, just in a rolling over format. For example, consider the table shown here, which indicates the movement of an index over weekly interval. So these are the weekly intervals, 8th, 15th, and so on, and this is the movement of prices over weekly period. Now this is a 10-week simple moving average, SMA. So 1, 2, and 3, 4, 5, 6, 7, 8, 9, 10. So if this is my first observation, this would be my 10th observation. The simple average of all these 10 observations is 966, and average of this is 96.6. So this is the summation, this is the average of 10 observations. So divide by 10, we'll get this figure. As we move 1 week ahead, so we move here, so now 10 observations are in rolling over format starting from 90 to 100, and their summation is 955 and average is 95.5, and so on. We keep on rolling on this window and compute the averages. So these are like simple moving average which are rolling over. Now please notice, while the index value may be fluctuating, its moving average is not as fluctuating and probably may result in a smooth and help us in identifying a smooth trend. Notice here, as the window rolls over, new week is added and old week is subtracted. Thus the average moves and therefore the term moving average. Changes in the price trends are identified by the price crossing MA. For example, if this is my moving average, which is rather smooth, fluctuating price can cross it from above or also from below. A change from a rising to declining market is signaled when the price moves below its MA like this. A bullish signal is triggered when the price rallies above the average like this kind of crossover. Since the use of MAs gives a clear-cut buy and sell signals, it helps to eliminate some of the subjectivity associated with the construction and interpretation of trend lines, because these are like dynamic support and resistance levels, or you can say dynamic trend lines. So an MA is a smooth version of a trend, and the average itself is an area of dynamic support and resistance, because it's like rolling over format. So the more times an MA has been touched, that is, it acts as a support and resistance area, the greater the significance when it is violated. To summarize this discussion, an MA is a smooth version of a trend. For example, this is a more smooth version as compared to the actual fluctuating prices. MA is more smooth, and the average itself is an area of dynamic support and resistance. In a rising market, price reactions are often reversed as they find support in the area of MA. If the rest of the evidence agrees, it is not a bad idea to wait for the price to reach its MA prior to making a purchase. Similarly, a rally in a declining market often meets resistance at a moving average and turns down. The more times an MA has been touched, that is, it acts as a support or resistance area, the greater the significance when it is violated. A carefully chosen moving average MA should reflect the underlying trend. Its violation therefore warns that a change in trend may have already taken place. A carefully chosen MA should reflect the underlying trend, and its violation therefore warns that a change in trend may have already taken place. If the MA is flat or has already changed direction, its violation is fairly conclusive proof that the previous trend has reversed. If the violation occurs while the MA is still proceeding in the direction of prevailing trend, this development should be treated as a preliminary warning that a trend reversal has taken place. Confirmation should await a flattening or a change in the direction of MA itself, or should be sought from the alternative technical sources like price formation or price patterns. Generally speaking, the longer the time span covered by the MA, the greater is the significance of a crossover signal. For instance, the violation of a 15 or 18-month MA is substantially more important than a crossover of 1 month 30-day MA. Reversals in the direction of an MA are usually more reliable than a crossover. In instances in which a change in direction occurs close to the market turning point, a very powerful and reliable signal is given. However, in most instances, an average reverses well after a new trend has begun, and so it is only useful as a confirmation. Characteristics of moving average. In this video, we'll discuss some basic characteristics of moving average plot. An MA or moving average is a smooth version of a trend, and the average itself is an area of dynamic support and resistance. In a rising market, price reactions are often reversed as they find support in the area of MA. If the rest of the evidence agrees, it is not a bad idea to wait for the price to reach its MA prior to making a purchase. After all, if the MA represents support, you can place a stop below support, that is, the MA. Similarly, a rally in a declining market often meets resistance at an MA and turns down. The more times an MA has been touched, that is, it acted as a support or resistance area, the greater the significance when it is violated. A carefully chosen MA should reflect the underlying trend. Its violation therefore warns that a change in trend may already have taken place. If the MA is flat or has already changed direction, its violation is fairly conclusive proof that the previous trend has reversed. If the violation occurs while the MA is still proceeding in the direction of the prevailing trend, this development should be treated as a preliminary warning that a trend reversal has taken place. Confirmation should await a flattening or change in direction of moving average itself, or should be sought from alternate technical sources such as price formation or price patterns. Generally speaking, the longer the time span covered by an MA, the greater its significance of a crossover signal. For instance, the violation of an 18-month MA moving average is substantially more important than a crossover of 13-day MA. Reversal in the direction of an MA are usually more reliable than crossover. In instances in which a change in direction occurs close to a market turning point, a very powerful and reliable signal is given. However, in most instances, an average reverses well after a new trend has begun and is only useful as a confirmation. A crossover is any penetration of an MA. However, close observation of any chart featuring MA will usually reveal a number of whipsaw or false signals. However, it is possible to avoid some of these close calls by using filter techniques. The type of filter to be used depends on the time span in question and is very much a matter of individual experimentation. For example, we may decide to take an action on MA crossover for which 3% penetration takes place and to ignore all others. What do we mean here is that, let's say, there is some kind of whipsaw price moves which confuse us. So to avoid these kind of whipsaws, you only consider them when there is a substantial magnitude. For example, look at this moving average. So now there is substantial sudden whipsaw signal, false whipsaw, and then price again comes back. So this indicates that there is about to be some kind of price reversal, but it is a false signal. So how do we avoid that? We put a cutoff band. We put a band. So this is our moving average line. This is the upper level. This is the lower level. Now this filter of 3% or maybe 5%, some kind of filter or band which can cut out all the whipsaw signals, and only those signals that are substantially large are considered useful. And therefore, violations of a 40-week MA might result in an average price move of 15 to 20%. In this sense, a 3% penetration would be a reasonable filter. On the other hand, since 3% would probably encompass the whole move signaled by a 10 RMA crossover, this kind of filter would be of no use whatsoever. So we need to use cautious judgment while selecting these filters. A useful tip is to wait for an MA crossover to take place at the same time a trend line violation also occurs or a price formation completed. Such signals strongly reinforce the trend line or price pattern signals and therefore need less in the form of filter requirement. For example, if an MA crossover has taken place at the same time a trend line is violated or a price pattern is completed, these signals strongly reinforce each other and therefore need less in the form of a filter requirement. Sometimes it's possible to see an MA crossover accompanied with exceptionally heavy volume. Just look at this diagram here. So here, this moving average violation or crossover occurs at the same time where the trend line violation also occurs. So trend line is also crossed and moving average is also crossed. Same here, the trend line is also crossover and moving average is also crossover, and the signal is much more strong here. So the reversal signal is much more strong. Sometimes this information can also be gauged from the heavy volume. In similar circumstances, you could lower your standards of what represented a decisive breakout, since the expanding volume would emphasize enthusiasm by the buyers or fear of sellers depending upon the direction of the break. To summarize this video, an MA is a smooth version of trend. We discussed some of the basic properties of MA. MA, the average itself is area of dynamic support and resistance. The more times an MA has been touched, the better it is to act as a support and resistance area, and greater its significance when it is violated. A carefully chosen MA would reflect the underlying trend and therefore its violation would be important. Longer the time span covered by MA, the greater its significance when there is a crossover. The problem with crossovers is that oftentimes there is a whipsaw or false signals that can confuse us, and therefore it is a good approach to have some kind of filter which filters out insignificant or small moves. Many times, if we have some kind of corroborative evidence, for example, trend line violation happening same time with MA crossover, or evidence from volume which corroborates the evidence from MA, then such kind of filtration may not be required. A more solid signal is generated. Signal generation with moving averages. In this video, we'll examine the application of moving averages in identifying price trend reversals and signal generation. If a moving average crossover takes place at the same time a trend line is violated or a price pattern is completed, then these signals strongly reinforce each other and therefore need less in the form of a filter requirement. Sometimes it's possible to see a moving average crossover accompanied with exceptionally heavy volume, and in such circumstances you could lower your standards of what represented a decisive breakout, since the expanding volume would emphasize enthusiasm by the buyers or fear by the sellers depending on the direction of the break. Notice the figure here. This cross was accompanied by expanding volume activity and also a trend line break, which indicates a very strong signal. In addition, there are two other breaks with expanding activity. As we can see, volume has expanded. In fact, for this particular break, the trend line is also violated and it was upside violation. The trend line is also violated, so the signal is particularly strong. The figure here features Eurotip index with 40-week MA, this 40-week MA, and two bands that have been plotted at 3% above and below. So the two bands are there, below and above the average itself. Buy signals are generated when the price crosses above this line, and sell signals are generated when it crosses below. Now, given the length of this band or amplitude of this band, many of the whipsaw signals are eliminated. Not very significant moves are eliminated because of this band itself. Only those moves where the band itself is violated. For sell signal, the lower side of the band, and for the buy signal, the upper side of the band is violated. Only those signals are considered useful. This has a very important effect of filtering out some of the whipsaw signals or false signals. Also, during a trading range, MA crossovers have a strong tendency to be counterproductive. In these situations, it is usually best to use the outer ends of trading range for signal generation rather than MA itself. Obviously, no one rings a bell to say that the price has entered a trading range, but after a couple of whipsaw signals, it becomes apparent. And that is the time when a well-constructed trend line for the trading range should be substituted for MA crossover. As we can see here, these are the trading ranges. Within these trading ranges, there are a number of whipsaw signals, and therefore such trading ranges offer useful trend lines. Only when these trend lines or trading ranges are crossed, then the signal becomes important or the signal generation is useful. Within this band, if we look at MA, there are a number of times false whipsaw signals that may create a false impression of breakout. Such false signals can be eliminated by constructing these trend lines where trading in ranges is identified, and those signals which are with signal generated within these trend lines can be not considered or filtered out. Please note that MAs can be constructed for any time period, whether a few days, several weeks, many months, or even years. Optimal selection of length is very important. For example, if it is assumed that a complete bull or bear cycle has 4 years, MA constructed over a time period more than 48 months will not reflect the cycle at all, and it may give this kind of expression. For example, if your bull run is like this over a 4-year period and you construct a moving average for this complete 4 year, you use let's say 48 months or 4 years itself, you get a straight line. So the moving average is not useful at all. This is because it smoothes out all such fluctuations. All such fluctuations are smoothed out that takes place during the period, and it will become more or less like a straight line if my average is for complete 4 year. And therefore, the straight line crossing through the middle of the data, almost middle of the data it will cross through, unless until there is a very sharp, some kind of sharp linear trend, it will broadly represent a straight line. So for example, over the period, if this kind of move for period, it will represent a straight line. So no signal generation would be possible. On the other hand, a 5-day moving average will catch every minor move in the stock cycle and will be useless for the purpose of identifying the actual top and bottom of the overall cycle. Even if the 48-month or 4-year average were shortened to 24 months, using the crossover signals would still cause the 24-month average to give a agonizingly slow confirmation of a change in trend. So it will be very slow. The 4-week average would be so sensitive that it would continuously give misleading or whipsaw signals. Only an MA that can catch the movement of the actual cycle will provide the optimum trade-off between lateness and oversensitivity. For example, 10-month MA. So for a fluctuating price like this, a very short period MA would also behave like this. So it may not be so useful, a very short period MA. And a very long period MA will be so slow that will fail to catch any trend. So it will be very slow. So a compromise between a very large period and a very small period is desirable. To summarize, in this video, we discussed the signal generation process with moving averages. We noted that if a moving average crossover is taking place at the same time a trend line is violated or a price pattern is forming, such signals reinforce each other and are very useful in signal generation. For example, some kind of expanding volume activity. Another useful feature is to use some kind of bands above and below the moving average to filter out whipsaw signals. We also noted that constructing MA or selection of a period is a reasonable compromise between the lateness and sensitivity. MA constructed over a very short period will be very fluctuating and would generate a lot of whipsaw and false signals, and an MA constructed over a very long period may miss out many useful signals. In this video, we'll examine the application of multiple simple moving averages in signal generation and trend determination. Notice the price movement in this figure here. And also 10-month moving average and 24-month moving averages are plotted together. The signal generation by 24-month moving average is amazingly slow, while 10-month moving average is reasonably fast as compared to 24-month MA. If you think that going smaller or lower in terms of duration, for example 4-week MA would be a good strategy, think again. It will be so fluctuating that you may not capture signal but mostly false moves or whipsaws, and therefore a reasonable compromise would be somewhere between 10-month to 6-month moving average for signal generation. Here a good strategy is examining the convergence of averages, how two averages converging together. Usually a sharp price move is often preceded by a gradually narrowing trading range like this: sharp price move and then trading range. In effect, decreasing price fluctuations reflect a very fine balance between buyers and sellers. Sellers who are putting the price down and buyers who are putting the price up. When the balance is tipped one way or the other, the price is free to embark upon a major move like this, up or down, depending upon which side wins, buying or selling. This kind of situation can be often identified by plotting several MAs, multiple MAs, and observing when they are all approximately at the same point or converging with each other. Have a look at this diagram here. The figure shows the daily price for cash euro yen. Notice the three MAs. Notice the three MAs: 10-day MA, 25-day MA, and 45-day MA. How these three MAs almost completely converge just before the price embarks on a sharp decline here. The convergence of averages, all the three averages are converging here, warns that a major move is likely. However, the actual signal comes from the violation of trend line here, after the violation, a very solid signal of price decline is there, and there's a very sharp decline. So all the three MAs converge, and then also a trend line violation from towards the downside, which indicates a down move. Many such techniques involve trend determination with more than one moving average. Signals are given by a shorter term MA crossing above or below a longer one. This procedure has the advantage of smoothing the data twice. For example, longer one MA, let's say here as you can see 10-week MA, there is one 10-week MA and 30-week MA. This reduces the possibility of whipsaw, and it warns of trend changes fairly quickly after they have taken place. For example, notice the shorter MA, 10-week MA is much more fluctuating, less fluctuating than price but is still fluctuating, while 30-week MA is much more smoother. And trend generation happens whenever this 10-week MA crosses over. There are some whipsaw signals, but a major signal here where actually the 30-week MA itself changes the direction. So when this short-term MA crosses towards the downside, there is a signal generation, but a more solid confirmation happens when this 30-week MA itself changes the direction. In the figure here, notice iShares MSCI ETF. The two averages of 10-week and 30-week are plotted. These have been identified or used to identify the primary trends. Signals are given when the dashed or 10-week, this is the 10-week MA, moves below the 30-week here average. In the previous diagram, some technicians may prefer to wait until 30-week series is moving in the direction of the cross. That is here, it is also turning. The 30-week MA is also turning. So a negative cross would require declining 30-week MA. Negative signals of either variety warn that a major trend is downside. It is not assumed to have reversed until either the 10-week MA moves higher than the 30-week MA, or it does so when both are rising simultaneously. By definition, either methodology results in signals being triggered after the ultimate price peak or trough. Therefore, they serve as a confirmation of a change in trend rather than the actual juncture points in themselves. If the signal develops close to the final turning point, then it can be acted upon in a timely and practical way. On the other hand, if it is triggered by some distance from the previous peak or trough, then it can be merely used as a confirmation. To summarize, in this video, we discussed application of multiple simple moving averages in signal generation and trend determination. We noted that a shorter duration MA is more fluctuating and it can be used along with a long-term MA in generating signals. Crossing over of short-term MA from up to down or down to up may indicate some kind of trend reversal. However, a very solid signal is generated when there is when the long-term MA also changes the direction, or there is some kind of trend line violation or confirmation from volume. MAs in trading range. In this video, we'll discuss how to examine when moving averages are in a trading range. MAs, moving averages, should always be used in conjunction with other indicators. This is because prices occasionally fluctuate in broad sideways pattern for an extended period like this. Here you can see moving average fluctuating in a sideways range pattern. This results in number of misleading signals like here. These are whipsaw signals, false signals. The good news is that such frustrating trading range action is often followed by a sharp, strong trend in which the losses incurred from the trendless period of whipsaw signals are more than made up for, like this. Or maybe in opposite direction also. Such sharp price action is expected because whipsaw signals indicate some confusion between buyers and sellers, and this implies a big battle between them. When one or the other party wins out, the victorious side is able to push the prices in a much stronger way. The figure here shows an example of an MA or moving average offering numerous whipsaw signals as it moves through a trading range. Notice this. In the beginning, it may not be very obvious that this is a trading range kind of sideways pattern. However, at point X, if one draws these trend lines within or rectangle pattern at point X, when the price crosses below the MA again, it is possible to construct these two trend lines that reflect this range action. At such a time, it makes it much better sense to wait the verdict by acting on a trend line break rather than MA crossover. For example, at this stage, it would be better to wait for this kind of trend line break, either on the upside or downside. This is so because there is no particular reason to believe that the next move like this crossing up would be a sharp move, and it will not be a whipsaw as was the case earlier. So we do not have any reason to believe that next move is going to be different than these whipsaws. So we prepare these kind of trend lines, and only when the price crosses these trend lines, then only we consider it as a solid signal. To summarize, in this video we discussed that often trading in range action or sideways pattern can be confusing, and therefore it is more advisable to set up trend lines in the sideways pattern like we can see here on the up and down. One can set the trend lines, and only when the price crosses these trend lines on the upside or downside crossover, then that should only be considered as a solid signal. In that case, MA crossing over the prices up and down may be a whipsaw, can be considered as a whipsaw and filtered out because of these trend lines. Weighted moving averages, WMAs. In this video, we'll examine the concept of WMAs and their computation through a simple example. A simple moving average SMA can only correctly represent a trend from a statistical point of view if it is centered. But centering an average delays the signal. Reason being, all the observations in SMA are given equal weightage, and therefore older observations drag the MA and makes it less timely. One technique that attempts to overcome this problem is to weight the data in favor of most recent observations, so that recent observations or the WMA can capture the more recent information. An MA constructed in this manner, or WMA weighted moving average, is able to turn or reverse direction with much more quickly than a simple MA. Let us understand the computation of this through a simple example. There are countless ways in which data can be weighted, but the most widely used method is a technique whereby the first period of data is multiplied by 1, second by 2, third by 3, and so on until the most recent one. And then the calculation for each period are then totaled. This is used as a divisor for simple MA, is the number of periods. But for this form of weighted average, the divisor is sum of the weights. For let's take example, if you have 6 observations, the most recent observations will be multiplied by 6, because there are 6 periods or 6 observations, then previous observation by 5, and the last observation by 1. The total of all these is 21, so the divisor will be 21. Similarly, for a 10-week WMA, you have sum of the weights from 1 to 10 as 55. The most recent observation will be multiplied with 10, the previous one with 9, and so on and so forth until the last observation will be multiplied with or given a weight of 1. Let's do this an example. This table we have seen earlier, we have computed simple moving average for this table where weekly index price data is given like this. Dates are provided and data shifts week by week. Now in the first set of observations, we compute weighted moving average by multiplying this 101 with 1, then 100 by 2, and so on and so forth until 99 is multiplied with the 6, because 99 is the most recent observation and 101 is the oldest observation. Summation of all these, which is 2080, is divided by 21, which is the sum of 1 to 6. Now when we are computing or shifting by one period and then 95 is the most recent observation, then 95 is given a weight of 6 and 100, which is the sixth observation or the last observation, is given a weight of 1. So 100 into 1, then 103 into 2, 99 into 3, and so on up till 95 into 6. All these observations are summed up to 2052 and divided by 21 to get this observation. Notice that these observations, the WMAs that we are computing here, give more weight to the recent observation, therefore probably generate more timely signals as compared to SMAs, which were slightly slow because they were giving equal weight to the most recent observations, same as the older observations. To summarize, in this video we understand the computation of weighted moving averages. We noted that SMA suffers with a simple problem that SMAs offer equal weight to old and new information, therefore generate a slightly delayed signal. To overcome this problem, WMAs, weighted moving averages, are employed where higher weight is given to the most recent observation and lower weights are given to older observations so that the signal generation is more timely. Exponential moving averages. In this video, we'll try to understand the concept of EMAs or exponential moving averages with the help of simple examples. An exponential moving average is a shortcut to obtaining a form of weighted MA itself. However, it offers an improvement by using this alpha or exponent. Notice the formula of EWMA. Here alpha is multiplied by the difference between the latest price and the previous period EWMA, which is EWMA T minus 1, plus the value of EWMA for the previous period itself. Now please notice the choice of alpha is very important here. If alpha is, let's say, very small, let's say close to 0, then this term will be close to 0 and the EWMA for the current period will be same as EWMA for the previous period. That means we are ignoring the latest information and we are considering the previous EWMA itself. So less weightage to the latest information. However, if alpha is very large, let's say tending to 1, then this becomes EWMA T minus 1 is cancelled and it becomes PT itself. So this will be cancelled because alpha is 1 and EWMA becomes PT itself. So all the weight is given to the latest price. So this is a trade-off, how much information or weight you want to offer to the previous observation vis-a-vis latest observation or latest information. Let's try to understand this concept with the help of simple example now. Notice the table here. We have already seen this table. Now we are doing the calculation for 20-week EMA as shown here. In order to construct a 20-week MA, first it is necessary to calculate, or we need that EWMA T minus 1, but we do not have that. So we'll take simple MA for previous 20 weeks. That works out to 99. So this is done for 20 weeks ending January 1st. The simple MA is computed. We'll use that as a proxy for EWMA T minus 1. It appears at 99. Now it is put here as previous period EWMA T minus 1. The 20-week average becomes the starting point for the EMA. It is transferred to column 2 for the first week. Next, the entry for the 21st week, January 8 in the example, is compared with the EMA. The difference is taken. So this difference between 100 minus 99, which is 1. Alpha here is the exponent. So this one is multiplied by 0.1. So we get the first term as 0.1 and this is added to the previous period EWMA T minus 1, which is 99, to get 99.1. Now this is our latest EWMA T minus 1. So we'll transfer this to the next week and the price is 103, again the difference would be taken, this 3.9 and multiplied with the exponent 0.39, and it will be added to 99.1. In a similar manner, we'll compute the EWMAs for all the weeks. Notice the choice of alpha or exponent determines how much weightage is given to the current or new information incorporated in this price. More the alpha, greater weightage is given to the latest information. Less the alpha, more weightage is given to the older information. Another very important aspect here is the choice of exponent. The correct exponent for various time spans are shown here by using this formula, 2 upon time span. On the left we have number of weeks, 2 divided by time span will give us the exponent. Time periods have been chosen as weekly. In effect, however, the exponent of 0.1 can be used for any measure of 20 days, whether it is month, week or anything. So 2 upon 20 would give us 0.1. Exponents for time periods other than those shown in the table can be easily calculated by dividing with 2. For example, 5-week average will need to be twice as sensitive as compared to a 10-week average. Thus, dividing 2 by 5 will give us 0.4. It gives an exponent of 0.4. On the other hand, a 20-week average should be half as sensitive for a 10-week period. So its exponent is 2 by 10, 2 by 20, which works out to 0.1. And so on. If an MA proves to be too sensitive for the trend being monitored, one solution is to extend its time period. And therefore, all forms of MAs represent some form of compromise between timelines and sensitivity. To summarize, in this video, we discussed the concept of exponential moving averages, EMAs. We saw the computation of EMAs with the help of simple example, and we also saw how to determine the exponent employed in the concept of EMAs. To summarize this lesson, one of the basic assumptions of technical analysis is that stocks move in trends. Since major trends comprise many minor fluctuations in prices, a moving average is constructed to help smooth out the data so that the underlying trend will be more clearly visible. Often, MA crossovers are employed to provide warnings of a reversal in trend, and using weighted moving averages or exponential moving averages, which are more sensitive to changes in the prevailing trend since they weigh data in favor of the most recent periods. There is no such thing as perfect average. The choice of time span always represents a trade-off between timeliness, that is catching the trend at an early stage, and sensitivity, that is catching the trend too early and causing an undue movement of whipsaws or false signals. In this lesson, we computed 3 main types of moving averages, including simple moving averages, weighted moving averages, and exponential moving averages. We discussed the advantages and disadvantages of these moving averages and their properties and applications. We also discussed the application of moving averages in identifying trend and trend reversals. We noted that moving average is smooth version of trend. The more time an MA is touched, the greater the significance attached to it, its violation and its role as support or resistance. Many times, moving average crossovers generate false or whipsaw signals. These whipsaw signals can be filtered out by using upper and lower bands around the moving average line. Signal generation with moving average follows weight of evidence approach. That is, other evidences such as volume, trend line, price patterns, etc. are also given due consideration. Selection of an MA period is a compromise between lateness and sensitivity. A small period MA can be extremely fluctuating, resulting in many false signals. A very large period MA will be very slow, but may not identify very useful signals. Often, a system of short-term and long-term MAs can be employed in signal generation. Here, short-term MA line is more fluctuating and its cross of long-term MA leads to signal generation. The signal generation strength is even more stronger if the long-term A itself changes direction.